Hello again. In this video we're going to be talking about multiplying polynomials, and in particular monomials, meaning one term. So the way that we multiply monomials, for example, if we just had something such as x cubed times x cubed, or let's just do x to the fourth. So the question is, how do I bring these together? How do I multiply them? So we have to ask ourselves what x cubed means. It means we're going to take x times itself 3 times, right? Same thing with x to the fourth. I would take x to the fourth times itself 4 times. So when I'm looking at this, they're all x's here, and they're all multiplying, right? This is, exponents are shorthand for multiplication. I'm multiplying, it's all multiplication, and it's all multiplying x's in particular. So if I wanted to write this right-hand side here exponentially, what I would do is bring it back together and say, well, I've got 1, 2, 3, 4, 5, 6, 7 x's, and I'd write x to the 7th. So the question is, how do I get from here to there without expanding it each time? We can notice a relationship in the exponents here versus where we ended. All we have to do is add those exponents. So x cubed plus, or sorry, not plus, x cubed times x to the fourth. We just have to add the 3 plus 4 and we get 7, right? Because this is made up of only x's being multiplied by x's. If I had other variables, I would just bring together the like variables, right? Multiplication is commutative, so I can multiply these in any order I want, and in between each, there's no plus and minus here. This is negative a squared times b cubed times c times 10. It's all multiplication. So we can reorder this however we want since it's commutative, and we bring together the like variables. So let's look at this example down here. Over here I have 3 monomials being multiplied, but it's still all multiplication. This says 4 times d times negative 2 times d to the fourth times this whole quantity of 3 times d to the 7th. All of this is multiplication. So we could rearrange this in any order we wanted. We could say 4 times that negative 2 times 3, and then times the d's. So because multiplication is commutative, we could rearrange that. And then I'm going to choose to multiply what I can multiply. So I can multiply 4 times negative 2 times 3. This is going to be negative 8 times 3, or negative 24. And then just like we did up here with the x's, d times d to the fourth times d to the 7th, this is 1d here, plus 4 plus 7. So I have 12 d's, or d to the 12th power. And that's as far as I can go with that. Try the 2 on the right. Okay, we're over here looking at 8w squared times negative 5w cubed. So you could choose to rewrite it if you would like to see the coefficients multiplied together and then the variables being multiplied together. Or you could just say, I know that I'm going to multiply the 8 times the negative 5 and get negative 40. And w squared times the w cubed, we're going to add those exponents and get w to the 5th. And down here, I'll do the same thing. I'll multiply the coefficients, and then the a's, and then the b's, and then the c's. So I've got negative 1. If it helps you, you could write a 1 here. Negative 1 times 10, you get negative 10. A squared times a, there's 1a over here. So a squared times a would be a cubed. B cubed times b squared, 3 plus 2 is 5, so b to the 5th. and c times c to the 12th, that's 1c over here, plus 12 would give me 13. And that's as far as you can go with that. Alright, so that's one term being multiplied by one term, versus here I have a monomial being multiplied by a polynomial. So one term being multiplied by many terms. The way we simplify this is by distributing. So whatever is being multiplied has to be distributed to every term inside the parenthesis. For example, I'll take 2y times 6y squared. So starting with the coefficients, 2 times 6 is 12, and then y times y squared would be y cubed. Then I'll take the 2y and multiply it by negative 8y. So 2 times a negative 8 is negative 16, and y times y would be y squared. Then I'll take that 2y and multiply it by a positive 3. So 2 times 3 is 6, and I still have that y. Same thing, even if it's a negative coefficient. I'm going to take negative 4w cubed times negative 2w squared. So negative 4 times negative 2 would be positive 8. W cubed times w squared is w to the 5th, right? 2 plus 3. Then I'll do the negative 4w cubed times a negative w. So negative 4 times negative 1 is positive 4. Then the w cubed times w, so this is w to the first power, will be w to the 4th. And then lastly, negative 4w cubed times 3. Negative 4 times 3 is negative 12. I still have that w cubed. Go ahead and try the one on the right. Alright, so we're multiplying 3z squared into our parenthesis here. Has to get multiplied to every term. Terms are separated by pluses and minuses. So I'm going to start with 3w squared times z cubed. And 3 times 1 is 3. Z squared times z cubed is z to the 5th. 2 plus 3. Then I'm going to do 3z squared times 6z. 3 times 6 is 18. And z squared times z is z cubed. So 2 plus 1. And lastly, 3z squared times negative 4. So 3 times a negative 4 is negative 12. And still with that z squared. And there you go. So whether it's one term by one term or one term by many terms, the way we approach it is multiplying the coefficients together and then multiplying the variables together. If we have like variables, we can add those exponents.